Okay, so we are talking about bit plane slicing. Okay, so we have assumed that there are 3 bits per pixel. Now, whenever there are 3 bits per pixel, we can get 3 binary planes, right? With a 3-bit number, we can represent by 3 bits. If you have a number 0, decimal 0, we can represent by 000. Similarly, number 1 we can represent by 001. And similarly, by using these 3 bits, we can represent 0 to 7, various decimal numbers ranging from 0 to 7. Yeah, say number 7 we can represent by 111. Okay, so this is an example of binary image. And this is an example of gray level image where we are using 3 bits. We are using 3 bits per pixel. With 3 bits per pixel, we can get 8 different values ranging between 0 to 7. And now we want to uh, convert this image to bit planes. Now, as we are using 3 bits, we can get 3-bit planes. Okay, so for 3-bit image, we can get 3-bit planes. Okay, so how we can get these 3-bit planes? For all these pixels, we can collect their least significant bit. We can collect least significant bit of all pixels to get least significant bit plane, LSB plane, or plane 0 we can get by collecting least significant bits of all these pixels. Similarly, we can get most significant bit plane by collecting most significant bits of all these pixels. And third plane, which is middle plane, we can get by collecting central bit or middle bit of all these pixels. Okay, so corresponding to 3 bits, we can get 3 binary planes. Okay, so in this image, your very first pixel is 6. Okay, so we can represent 6 by 110, right? We can represent 6 by 110. We can represent 7 by 111. So in order to perform bit plane slicing, first represent all the pixels in binary form and then collect most significant bits of all pixels to get most significant bit plane. Then collect middle bits of all the pixels to get uh, binary plane equivalent to middle bits, and then collect least significant bits of all these pixels to get binary plane corresponding to least significant bits. Okay, so this is your input image and this is binary representation. Now collect all these bits, very first bits, collect all these most significant bits to get most significant bit plane. Okay, so you will get most significant plane and then collect central bits. This is central bit for all the pixels. Okay, collect central bits to get second plane and then collect least significant bits. So these are least significant bits. Collect these least significant values to get the LSB. Okay, this is meaning of bit plane slicing. Okay. Let me erase these things. Okay. So this is when we collect most significant bits, we get uh, least MSB plane, which is of same size as your original image. In your original image, there are 5 rows and 5 columns. So total there are 25 pixels. Okay. So we get most significant bit plane of same size, that is 5 by 5, by collecting most significant bits from this data. So we have collected uh, most significant bits to get this most significant bit plane. Similarly, we obtained this central bit plane by collecting middle bits of each pixels, and third plane, which is your least significant bit plane. Okay, least significant bit plane by collecting LS bits from each of the pixel values. So did you understand what is meaning of bit plane slicing? If you have understood, we can go to next slide. Okay. So basically, we try to represent gray image in terms of binary planes. So if you have 3 bits per pixel, we will get 3 binary planes. Now, if I have 4 bits per pixel, how many binary planes I can get for the given gray image? If I am using 4 bits per pixel. Yes, Sharon, Soumya, Sakshi, Mehak, all of you have given me correct answers. If we are using 4 bits per pixel, we will get 4-bit planes. And usually we have 8 bits per pixel for representing gray images. So for those images, we will get 8-bit planes. Okay. So this for this particular for this original image, which is gray image, and this image is represented by using 8 bits per pixel, we will get 8 different binary planes, and those 8 binary planes are shown in this particular figure. Okay, so when we represent it as binary planes, binary images, your most significant bit plane will look like this as shown here. This is next most significant bit, that is at location 6. Uh, we can collect pix, location, bits at location 6 from all the pixels in the given image. So this is your original image, and this is binary plane, uh, say numbered 6, binary plane 6, uh, as displayed here. Then this is next plane, that is bit plane, by using bits at location 5. Then this is next one, and this one is least significant bit plane. Okay, so here at least significant bit position, all LSBs of all the pixels from original image are collected, and this array is displayed here a a binary image. Okay, so if you look at these pictures, you can easily say that your most significant bit plane is more closer to your original image. So these most significant bit planes, say this is 7, 6, 5 and 4, they are giving you significant information about your original image, and these least significant 4 planes, that is 3, 2, 1, 0, they are giving you details, minute details in the image. Okay, so compared to first 4 planes, last 4 planes give you less significant information. Okay, but they can contribute to minute details as shown here. Okay, so one advantage of bit plane slicing is you can directly focus on most significant planes in order to enhance your image. And second advantage is you can apply binary compression techniques on each of these images, like run length coding or block coding, constant white area coding techniques. These techniques, which are available for binary images, those images, those compression techniques you can directly apply to these binary planes. Okay. So there is one more example. I request all of you to represent this input image as by bit plane images. Okay. Now all of you tell me how the most significant bit plane will look like for very first row. Only give me answers for first row because all the rows are identical. So same answer you will get for next all rows. Okay. So just tell me bit string corresponding to most significant bit plane for the given example. Most significant bit plane for very first row in the image. Very good, Sharan, Mehak, Sakshi, Pranav, all of you, Soumya, all of you have given me correct answer. So for for first two pixels, most significant bit is 1 because we represent 7 by 111. For next two pixels, they have value 3. We represent 3 as 011. So most significant bit will be 0 for next two pixels. And for this last pixel, how we represent 1 in binary 001. So again, most significant bit is 0. Okay. So for very first row, your answer is for most significant bit, it is 11000. Okay. So all of you have answered me correctly. Very good. Now I am expecting answers from other students. Tell me how the least significant bit plane will look like for very first row in the image. Type it as bit string. Sharan, your answer is correct. What about others? Only few students are answering. I'm expecting answer from other students. Don't type your attendance right now. Yes, Soumya, your answer is correct. What about others? Many participants are there. Abhijit, Abhiraj, Daddi, Afan, Akshata, Bhushan, Chaitanya. Give me your answer. Chirag, Gargi, Manas, Pranjal, Pranav, Pranay, Sai. None of these students are typing answers. Only few students are responding. What about others? Okay, so I'm giving you answer for first row. Least significant bits will be all ones because for all these decimal numbers, its binary equivalent least significant bit is 1. All of them are odd numbers, so least significant bit is 1. So your answer is 11111. So for this given image, this is your most significant bit plane, this is least significant bit plane, and this is your middle binary plane. Okay, that is representing central bits for all these numbers. Okay, so this is about bit plane slicing. Now, one more important point processing operation, that is image negative. So image negative is very simple operation. We subtract every pixel value from maximum possible bright value. Okay, and we can get inverted image or negative image. So mathematically, we can represent it using this equation. Modified or enhanced gray value S is equal to L minus 1 minus R. Okay. So where L represents total number of gray values. Okay. So if we are using 8 bits per pixel, L minus 1 is 255. So simply we can subtract original pixel value R from 255 to get the image negative or enhanced image. Okay. So S is the pixel value of the output image and R is the pixel value of the input image, and L represents total number of gray levels. Okay. So for 8 bits per pixel, total number of gray levels are 256, and hence L minus 1 will be 255. So now this is an example of 8-bit gray image, which is a mammogram of breast, and the mammograms are useful for detecting breast cancers or abnormal tissues in breast. So there is an abnormality which is highlighted as bright shade in the given image. Now, if we take negative of this image, we are getting this image. So how we obtain this negative? We start with very first pixel. We subtract that pixel value from 255. Okay, so this first pixel value is very dark. Say this level is 10. So 255 minus 10 results in a very bright shade, which is 245. Okay, so all initial pixels, all the pixels in this particular region, they are replaced by bright gray value, which is 245. If we assume this level as 10. Okay, similarly, we subtract each and every pixel value from 255 and we get this image negative. And if you look at this image negative, you can easily identify the abnormality. Okay, so this simple image negative operation is useful in many applications. Okay, so this is image negative is simplest point processing operation. We are, why it is point processing? Because we are applying some function on every pixel of the image. Okay, and the given function is 255 minus R. Okay, so this is image negative operation. Now with we will go to next point processing operations in the next lecture. And now I request all of you to type your attendance in given format, that is 5 digits or last 5 digits of your PRN number, followed by space, followed by your name. Thank you all. If you have any queries, please unmute and ask. Otherwise, type your attendance and you can leave the meeting. Thank you all.